Hi, my name is Dr. Bill Gutman. I am the Director of Aerospace Operations at Spaceport America. At Spaceport America, we launch items into space on a fairly regular basis. We launch rockets several times a year, and very soon we're going to be launching people into space with our anchor tenant, Virgin Galactic. But I want to talk to you today just a little bit about what it really means to be in space. And I want to do a couple of experiments that will help you understand that. So first of all, we kind of agree worldwide that space begins 100 kilometers above the surface of the Earth. That's about 62 miles. Now, normally when we get to space, we get there by moving very fast. The rockets we launch at Spaceport America are what we call suborbital rockets. They go up and then they immediately come back down under the influence of gravity. But in getting there, they normally reach speeds of about 3,500 miles per hour. So if you think about what that means, if you can get there to a place by car in 1 hour, then you can get there on one of these rockets in about 1 minute. Okay, so let's talk a little bit about what it means to be in space then. So one of the things about space is that we think of regularly is that it's sort of a vacuum. There's very little air up there. So we have ways of actually demonstrating what atmospheric pressure can do and what it would be like to be in space. So the first thing I want to do is show you an experiment of what air pressure does. So I'm talking to you today from Las Cruces, New Mexico. We're about 4,000 feet above sea level here. And at our elevation, air pushes down on every square inch of anything with a force of about 12.5 pounds. If we were at sea level, atmospheric pressure is about 14.7, almost 15 pounds on every little square inch. So what I'm telling you then is that the air pressure is effectively trying to crush this bottle. But obviously the bottle's not being crushed, and the reason for that is that there is air inside as well, and it pushes back with exactly the same force. So if you've ever done the experiment where you've used your mouth to sort of suck some of the air out of a soda bottle, you've seen how you can partially collapse the bottle, and that is because then the air inside there's less air inside, it's not pushing back as hard, and consequently the bottle is partially crushed. So I have here something called a vacuum pump. This vacuum pump can do exactly the same thing that you can do with your mouth, except it does it a lot better. So let's see what happens if I pull the air out of this bottle. So what I'm going to do is I'm going to hook up the bottle through a series of pipes to this vacuum pump via this hose. So I've done that now, and so I can turn on the vacuum pump. It's going to make a little bit of noise, and we'll have to live with that. Unfortunately, that's what they do. So it makes a little bit of noise. Now, I've opened the valve, and as soon as I open this valve right here, we'll pull the air out. So let's see what happens. So as you can see, this vacuum pump very effectively pulled the air out of the bottle, and that 12.5 pounds of air pressure per square inch just very, very effectively crushed the bottle.